Hello everyone. In our previous videos of the Learn Python series, we discussed functions, variables, lists, and loops in Python. Today we are going to install and use NumPy, a powerful library created by Travis Oliphant, commonly used for working with arrays and performing numerical computations. So let's start with installing NumPy. For that, open your command prompt and write pip install NumPy. You can enter and then NumPy will be installed. I've already installed it. Okay, so first of all, we need to import the NumPy library. So for that, we need to write import NumPy as NP. So by this, you won't be needed to write NumPy again and again. Instead, you can just use NP as its other name. Okay, so first is to make an array. ARR is equal to np dot array 1, 2, 3, 4, 5. Now if we print this, you can see 1, 2, 3, 4, 5, the array is printed. If we want to check its type, then we can simply write type ARR numpy.nd array. The array object in NumPy is called nd array. Now let's talk about 0D array. So each value in an array is a 0D array. It is also known as scalars. They are the elements in an array. So 0D array and in bracket 42. Then if we print the ARR, okay, this question mark is written mistakenly. So you can see 42 is printed. Now if we come to 1D array, an array that is 0D array as its element is called 1D array or one-dimensional array. 1D array. ARR is equal to mp dot array parentheses and square bracket 1, 2, 3, 4, 5. And then if we print this, you can see the array is printed. It is a 1D array. Now we will move to 2D array. An array that has 1D array as its elements is called a 2D array. These are often used to represent matrix. ARR is equals to np dot array 1, 2, 3 and 4, 5, 6. Then parenthesis closed and printing this array. You can see it is printed. It is a 2D array. 1, 2, 3 and then 4, 5, 6. Now let's see 3D array. Now you can guess the definition of 3D array. An array that has 2D arrays as its element is called 3D array. ARR equals to np dot array 1, 2, 3, then 4, 5, 6 and 1, 2, 3. Then you can write 4, 5, 6. Now if we print this one, you can see a 3D array is printed. Now next is to check the dimensions. For this you need to write like b equals to np dot array 1, 3, 4, 5 and then print this. So you can see its dimension is printed as it is a 1D array. Now if we want to create an array with 5 dimensions and verify the same, then arr equals to np dot array 1, 2, 3, 4, then n dimension is equals to 5 and then we will print this. Okay, so I have written the wrong here. It's ndmin. You can see array is printed and its dimension is 5. We can print the dimension as well. Number of dimensions. arr dot nd. You can see it has printed that the dimension is 5. Okay, so let's move further to array indexing. So if we need to access an array element, or like if we need to print an array element, then arr is equal to, let us take the same array, this one. If we need to print the element which is at the 0th index, then just close it in square brackets. So you can see at 0th element is 1. My at 0th index the element is 1 and so it is printed. If I need to add 2 elements or arrays, adding, you could just copy this one. So adding 2 elements means we need to give their indexes and put a plus sign between them. You can see at the 0th index is 3 and for third index is 4. 3 plus 4 is 7. The next thing is to access the element into the array. If we'll take a first row and second column, the element at first row and second column. And first we need to write a 2D array. Six comma 7 comma 8 comma 9 comma 10. Now if we print the second element on the first row, it will be in square brackets 0 comma 1. So first is the index of row comma index of column. If I run this, you can see 2 is printed. So 0 is this and 1 is this. So 2 second element is printed. Let's move further. If we want to access the third element of second array of the first array, then first we need to write the array 1 comma 2 comma 3, then 4 comma 5 comma 6, then 7 comma 8 comma 9, 10 comma 11 comma 12. Then we will print it said first array. So first array means 0, then second array, so it means 1, and third element, so it means 2. So it should print the value 6, this one, because it said the 0th one is this, then the first one is this, and then the second one is this. Let's see. Indeed, it has printed 0. I mean 6. Now if we want to print the last dimension, oh, I'm sorry, last element from the second dimension, we can just have this copied. So last element from second dimension means print ARR, then index 1 comma minus 1. This is because it said second dimension. Second dimension, it will be 1, and last element. So we can just use the negative indexing, which is minus 1. So 10 is printed because 1 is this and then last element. Now the next thing is slicing. So if we have an array, mm, we can copy this one and add a few more elements to it. X 6, 7. If we want to slice from index 1 to index 5, from index 1 to 5. Then what can we do is just print with a range from 1 to 5. You can see from 1 to 5, but the last number is excluded as I've already told you in my previous videos. So it will be 1, 2, 3, and 4. Now if we want to slice it from index 3 to index 1 from the end, then we can again use the negative indexing like -3 to -1. We can just write -3 to -1, then it will slice from end, from the index 3 to index 1. Now if we want to use the step value to determine the step of the slicing, like for example, if we take this array only and we need to slice alternatively from 1 to 5, then we can just put colon 2. You can see 2, 4, and this is not in range, so 2 comma 4 is printed. Now if we want to slice a 2D array, we can take a 2D array from here. We can simply write. If we want to slice it from index 1 to index 4 from the second element, so 1 comma 1 colon 4. So you can see a desired output 7, 8, 9. If we want from both elements to return index 2, then what can we do is from both elements. So 0 colon 2 comma 2. So you can see 3 and 8 are the indexes 2, and from both elements we have taken index number 2. Now NumPy have many data types like if integer, b boolean, u unsigned integer, f float, c complex float, and so on like that. Now if you want to check the data type, let's say with a 1D array. If we want to check its data type, then what can we do is to simply print arr dot d type. You can see its data type is printed. If we want to create an array with data type string, then we can just put a comma and write d type is equal to s. S is for string. We can even print the array this time. You can see the array is printed and its data type is also printed. For I, U, F, S, and Q, we can define size as well. If we want to create an array with data type 4 bytes integer, then we can just write I4 for 4 bytes integer. You can see we got this result. Converting data type on existing arrays. Change data type from float to integer by using I as parameter value. Now if we see arr equals to np dot array 1.1, 2.1, 3.1. New arr is equal to arr dot s type I. Then if we print this new RR, also print its data type. You can see the new array with its data type is printed. And you can see that the float value have been converted into integer. Like here it was 1.1 and there when it's printed. Now NumPy array copy versus view. So if we want to make a copy, change the original array and display both arrays, then just write any array and write x equals to arr dot copy parenthesis, and we can even define some change in value according to index, like 0th index element should be converted to 42, whatever its previous value is. Then if we print both arr and our new array x, then you can see we changed the 0th element index element in arr and x was its copy. But we made the copy before changing this, and so x is not changed, whereas arr is changed. Its first element become 42, whereas x is having the initial value of of our arr. Now, if we want to view this array, means to make a view, change the origin array and display both arrays. So for this, we have already written our array above. Just write x is equals to arr dot view, and then if we modify this first element and print both of these, then let's say, so both have modified. This is because x is just the view version of this array, means our array is not copied in x, instead we are just viewing it through x. So both of things have changed. If you want to check if array owns its data, print the value of the base attribute to check if an array owns its data or not. So for this, just take this. We have to write again the same, that copy and view. And then we will print x dot base and y dot base. you will see that the result will be that copy will return none because it owns the data, whereas view returns the original array. So you can see our x is copy 1 and it has written none because it owns the data, and y was view and it returned our original array. So that was all for this video. Thanks for watching. Make sure to like, share and subscribe for more coding content. Happy coding!